Hi everyone, and welcome back to my channel. Now I know it's been a while since I've done a video, but to be honest, I've been spending the last few weeks trying to refine the various techniques that I've been using to build the base that's the subject of this video series. Specifically, and as I mentioned in my last video, I've been focusing on carving a new neck shaft for the base. Now I say new because I've already carved a complete neck shaft and a fretboard, which came out nicely, but not as nicely as I'd hoped. So I decided to go back to the drawing board and work on my technique a little bit, experiment with some settings on my CNC machine, and see if I could improve on the final product. So what I'd like to do in this video is stick my necks out, so to speak, show you some of the necks that I built in the short time that I've been building bases, and discuss the process, including things that went right, things that went wrong, things that I've learned along the way, and things that I've changed. So sit back and relax, and I will show you some necks. So the first neck I'd like to show you is also the first neck that I ever built. This is the prototype neck for the BR6 base. That's the base that I built for my nephew. You can see videos of that base on my YouTube channel. Now you'll see that it's a three-piece laminated neck. It has hard maple wings and a walnut center stripe. The fretboard is Indian ebony, and I also made like a little head plate out of ABS plastic and put a little logo on there. Now I learned a ton building this neck. Not least was how to drill holes for position markers and install them, how to drill or carve slots for frets, how to radius a fretboard, how to mate the fretboard to the neck shaft. I mean, all kinds of things. And I have to say, this neck plays really beautifully. I actually bolted this neck onto a prototype body and I strung it up and got it all adjusted. And I have to say, the action is every bit as good as any base that I've ever owned, any base that I've ever purchased. And the neck really plays beautifully. It has some cosmetic flaws that I can easily fix. I made some decisions in terms of finish that I would revisit. If I had a chance to do it over again, I wouldn't use the finish that I used. I wasn't crazy with how kind of amber toned it got and vintage looking. I like them a little brighter. But nonetheless, this thing plays great. And mark my words, it will end up on one of my bases one of these days. So the next neck I'd like to show you is actually the first neck that I carved for the base that's been the subject of this video series. Now I did a couple videos showing carving the neck shaft and then also the fretboard, but where this neck really got derailed was afterwards when I went to glue the fretboard to the neck shaft. Now if I hold it up to the camera, you'll see there's a very noticeable seam there, which is a cardinal sin when you're dealing with a maple neck and a maple fretboard. It should be invisible, almost unnoticeable, but nonetheless I ended up with a terrible seam, and I made that worse by taking a scribe tool and trying to inscribe a very kind of uniform line along that seam. I only ended up making it look more ragged and less professional. So at that point, I chose to set this neck aside and take an opportunity to think about other aspects of the design that I might not be totally happy with at the moment. One of those was the fact that the neck feels a little too chunky. Especially here on this edge, it feels a little too much like a baseball bat or a club, and the neck I'm modeling this after, the SR6, is much slimmer. So I thought, here's a good opportunity while I'm going back to the drawing board to kind of improve upon the design in my 3D model and hope for something similar, more similar to what I'm shooting for in the final output. So I went back into my 3D model, corrected some errors, and hopefully those will be resolved in the final product when I go to make another version of this neck. Okay, so in the last segment, I mentioned a final product. Now, I wish I could be sitting here right now showing you this and saying this is the final product, but I can't. Why, you ask? I mean, it looks pretty good. It's very smooth. I fixed all the problems that I discussed in the last segment in terms of the neck profile. Now it feels much more like the Ibanez SR6 that I've been modeling these necks after. It's a pretty nice looking neck. Well, let me tell you, it was one of the most difficult carves I've ever had. The carve took probably, I want to say 6 or 7 hours. I had to restart the carve twice because of errors. One of them involving a brief power outage and the other one where the bit just broke because I was probably running the machine too aggressively. So what you're seeing here is actually the end product of me taking the final CNC carve and correcting a lot of the issues. Particularly, I got a lot of what they call chatter on this carve, and that is where the bit is being pushed so hard or being asked to do so much that it starts to deviate from a perfectly vertical kind of carving position and move side to side. And that introduces a lot of little marks in the wood that have to be sanded out, smoothed over, whatnot. And I spent a lot of time doing that to this neck and got it in great shape, only to learn that taking all that wood away, sanding all those chatter marks out, made the neck too small to fit in the neck pocket for the body. And that again is a deal breaker. It's got to sit in there really tightly. It can't be moving around. Otherwise, just tuning it up or making any kind of adjustment could cause it to shift a little bit in that pocket, and then your bass is out of tune. I can't live with that kind of unreliability. You could never sell an instrument in that kind of condition. So I ended up ultimately with a really nice final product, but it took a ton of extra work to get it into this shape. And the bottom line was right out of the gate, I just simply messed up by using speeds, what they call feeds and speeds on my CNC machine that were just too aggressive. Luckily, there's a really robust online community where you can go ask questions when you've had a disaster or a catastrophe at the machine, where you can ask questions and people will give you advice on what to tweak and what to change to get a better result. And I did precisely that. And one of the gurus on that in that community basically informed me that I was running the machine at RPMs that were just too high for the kind of wood I'm cutting through, the kind of bit I'm using, and the kind of job I'm trying to do, and the result I'm trying to get. So I have since gone back and made some adjustments, and the next neck I'm going to show you is kind of a product of those adjustments, and it came out pretty nicely. This one, I don't know what I'm going to do with it. It's a great neck. I mean, it looks beautiful. I've smoothed out all of the imperfections and it's kind of ready to go. Probably what I'll do is just carve another body that is sort of where the neck pocket is sized for the neck rather than the other way around. Like usually the body has a fixed size for the neck pocket and I just make the neck correspond to that. But since I had to sand away so much wood to smooth out all the imperfections, I will just tweak the body design so that it accommodates the dimensions of this specific neck. Because I want to use it. It's a really nice piece of wood. It looks pretty nice. There's an imperfection on the heel, a little knot, but that's going to be covered because that's going to be sitting in the neck pocket. Other than that, it looks beautiful. So we'll see. I think I can salvage this one. But again, this is probably not going to end up on the bass that's been the subject of this video series. All right then. So here is the last neck I would like to show you in this video of me sticking my necks out. As you can probably tell, this is not going to be the final neck for the space project that I've been working on in this video series. Instead, it's just kind of an interim neck that I carved using another blank that I had sitting around for the purpose of testing some of the changes I've made to my process, to my settings, all of that stuff that I've been discussing throughout this video. Principal among the changes I've made is the method that I'm using to clamp the workpiece down to the CNC machine so that it doesn't move. Now, this might be a good time to kind of refresh your memory on how this all works. So, what I usually do is I start with a blank and I clamp it to my CNC machine. Now, at some point, I'm going to carve out a piece of wood from this blank, and the piece of wood that I carved out has to also be secure to the work table. Otherwise, it's going to go flying around as soon as it comes into contact with the CNC bit. Traditionally, we use tabs for that, and those tabs keep the finished workpiece mated from the remainder of the original blank, which ends up looking like this. And you can see right here's where the tab connects to the tab on the finished workpiece. That's all designed to keep everything from moving around and not flying off the table. So it's crucial that both pieces, the finished piece and the remainder, are fully secure to the table. So I think I've come up with a system to accomplish that without having to use all these tabs. Now, why do I have so much against these tabs? It's a perfectly legitimate and common solution. We all use them, and I even probably will have to keep a couple of them in some instances. But these tabs are really hard to remove and smooth out so that you end up with a nice finished workpiece that isn't compromised somehow. A lot of times the tabs will introduce little errors that force you to sand away more of the material from the finished product than you would prefer. So I'm trying to come up with a solution that avoids tabs as much as possible and limits them, frankly, to perfectly vertical surfaces like this, and excludes them entirely from curved surfaces like the curved part of the neck shaft. So what I'm going to show you in the next segment is the little jig that I've come up with that hopefully will accomplish that. Okay, so as promised, here is the clamping jig that I designed and built and used on the carve that produced the neck shaft that I showed you in the last segment. It's pretty simple, and I'm going to try to explain it. It might be hard to visualize, and you might need to wait till I actually can show you some video of this jig in action when I go to carve what will hopefully be the final neck shaft for this base project. But in a nutshell, the jig is designed, first of all, to be screwed down to the table using these slots so it doesn't wiggle around or move. But then after that, these lateral clamps that you see here are meant to hold the blank in place primarily. So I put the blank on this jig. I use these clamps to hold the blank in place. However, as I've been describing, I also need to have some method to hold the finished product, the result, in place once it is liberated from the overall blank. In other words, I need to hold this piece down to the table as well as this piece. What I've done is I've come up with a system whereby I use some holes to insert some what they call threaded inserts into this part of the neck. Those end up being basically embedded in the blank at various places, and then I use some screws and these slots to clamp the blank down to the jig so that it's clamped in two places, both laterally to keep the overall blank in place, and then with these threaded inserts from below to keep the final product from moving around once the two are separated by the CNC machine and it's done carving. So that is the plan. It worked when I carved this neck shaft, and I'm hoping it's going to continue to work going forward. And I also hope to show you this thing in action in a upcoming video, hopefully sooner rather than later. But I'm pretty optimistic about this method. I think it's going to save me a lot of trouble when it comes to not having to deal with tabs. I think it already has demonstrated that it's incredibly secure and stable. When I did this carve, this piece didn't budge at all, nor did the blank itself. The thing just was completely rock solid. The whole carve didn't have any problems with it moving around. And the good news is these little threaded inserts end up in a portion of the neck that's just going to be covered by the fretboard. So there's no downside to putting like this little hole here, here, and here in the truss rod slot and then the heel of the neck. It's a great way to stably anchor what ends up being the finished product to this little jig, which itself is anchored to my CNC table. So everything's real stable, and I don't have to worry about all those variables and all those issues that happen just due to lack of sufficient clamping. So many of the problems I've run into are because the workpiece just wasn't clamped securely enough to the CNC machine, and I got a vibration or I got some flexion here, let's say, and just the pressure of the bit traveling over the workpiece and doing its thing can really produce some skewed results if this thing is not completely immobilized. I think I've come up with the means to accomplish that now. But we will see. The proof is in the pudding. I hope to make that pudding in an upcoming video, and I look forward to seeing you then.